So hopefully you've all come and gone from school and gotten your resources for the new chapter we're going to do in biology. But if you may have noticed, I gave you a chapter 10 packet for notes and everything else. And that means we skipped chapter 9. Now, we normally don't do chapter 9, so that's not really a big deal. Just understand we did finish our genetics unit, and now we're going to be entering a new unit about evolution. So this first section in chapter 10, we're going to examine early ideas about evolution, and we're going to talk about those geologic theories that influence scientific debate over evolution in time. But before we can even talk about that, I would be remiss not to have a conversation with you guys about something that makes people uncomfortable, right? For whatever reason, people think that when I'm teaching about evolution, that I may be attacking certain viewpoints that people have, right? Now, what we all need to understand is that there is something called faith, but you also need to understand what the definition of faith is, right? So if you look that up real quick with a Google search, you'd see that faith means that you have a complete trust and confidence in something, right? Even in the absence of proof, right? Evidence that that's definitely true, right? Now, understand that faith does not mix with science very well because science is based in evidence, always, right? And faith, by definition, doesn't have to have any evidence. So that's where the conflict comes into play, right? So understand, science is based in evidence, but science and faith are not necessarily mutually exclusive. There are many scientists who devoted much of their lives to trying to prove that God exists, right? But that's not something that we're going to teach about in school because we've never found any evidence for that, actual concrete evidence that we could use to show that that's true, right? So we're going to talk about evolution and understand that we have a lot of evidence for evolution, right? Mostly, we have a ton of evidence for microevolution. We know that organisms change in time, right? Even short periods of time. So microevolution undeniably is a thing. It's not something you can argue about even, right? There are some extensions to evolution that we're going to deal with. We're going to talk about creation ultimately and common ancestry between different organisms. And now, although we don't have absolute proof that those things work the way that we describe, the theories that I'm going to teach you have tons and tons of evidence to support these things, right? And no evidence to contradict them. So there's no reason for us to believe that those things are wrong necessarily, at least based in evidence, right? So again, just make sure you understand that I'm not trying to attack anybody's faith. That's not the purpose of teaching you evolution. The purpose of teaching you evolution is to help you gain knowledge that's evidence-based so that you can decide what you want to believe, right? And how things work. So I just need to make that clear. I know it's kind of a strange conversation to have, especially when I can't talk to you guys directly and have you ask questions. Right, so if anybody wants to email me any questions, talk to me about it, that's perfectly reasonable. But otherwise, we're going to jump right into stuff here at our new notes. You got all these definitions, so I'll just put them all on one slide so you can fill in some blanks really quick. So if you want to just hit pause and then fill in the blanks and then start up the video again so I can talk about these things, that'd be perfect. But anyway, evolution is biological change in which descendants differ from their ancestors, right? By definition, evolution is just organisms that change in time, right? And we know, like I said, that that's absolutely true. It's not a thing that can be refuted. Organisms change over time, period, right? Species, we've had that definition before. Remember, it's a group of organisms that are similar and can reproduce to produce fertile offspring. Again, the only reason we needed that extra little add-on there to produce fertile offspring is because otherwise you would call lions and tigers the same species. Right? They can reproduce, but that liger can't, remember. So again, donkeys and horses, they can technically reproduce, but they're not the same species because their offspring's infertile, that mule's infertile. Fossils, traces of organisms that existed in the past, they play a very key role, obviously, in evolution. Using fossil evidence, we can track changes over time, right? Hopefully, right? There are a lot of missing fossils because not everything that dies makes a fossil, right? Dies in the exact conditions needed to make a fossil. So it's not to say that it's perfect, but it can give us evidence of change over time, especially when we see organisms in fossils that don't exist today, right? We know that things had to have changed, right? It's very key that we didn't know to think about evolution until we found fossils that were crazy, monstrous organisms, those terrible lizards, those dinosaurs. That's part of the whole deal, right? Dinosaurs never existed when we did. So for us to know that they existed actually made a pretty big difference, right? That helped us gain a better perspective and know that things probably changed over time. Otherwise, catastrophism, gradualism, uniformitarianism, two of those things are essentially the same. The gradualism, uniformitarianism, they're kind of the same thing. They can get lumped together a lot, right? But catastrophism is where we have natural disasters that have happened during Earth's history, changing the landscape, right? When we talk about catastrophism, that was an early theory, right? There was a time when we thought that great floods and earthquakes and things like that would create change, obviously. So instead of thinking of the Grand Canyon as forming over time by erosion, right, as a river ran through it, you would believe that a giant earthquake just split the earth open, and that's why there's that huge cavern, right? So that was an early theory, right, that switched gears to gradualism eventually, right? Scientists began to realize that there were those slow processes like erosion that could change the Earth's landscape. Right? So understand the difference between those two things, and then uniformitarianism just takes gradualism a little bit farther. Right? It's starting to talk about how there's this constant gradual rate of change that's still occurring. It's ongoing. Right? It's still happening as we speak. So organisms not only have changed, right, with that changing environment, but they will change in the future because our environment's changing. The questions in this set of notes in this first section explain why Darwin cannot be truly considered the father of evolution, right? If you wanted to answer that question literally, you'd probably talk about how his grandpa had that idea before he did. So as you work on your study guides and you see in this section that there were other scientists before Darwin that talked about this theory, that talked about the possibility of evolution occurring, right? That's how you answer this question. Now, Darwin is considered the father of evolution because he's the guy that came up with the mechanism. He's the one that came up with that natural selection that we talk about later, right? But it is important to consider those other scientists and what they contributed. So we're just going to throw those in here real quick, right? The first one was Linnaeus, and his contribution, he started to classify organisms, living things, based on how they're similar to each other, right? So again, starting to classify them based on how they're similar. You put cats together, dogs together, you put plants together, right? You're starting to understand that those are not necessarily separate things. They could possibly be related to each other. So that's where Buffon comes in, right? His contribution is starting to talk about, not only are those things grouped together because they're similar, but maybe they're related to each other, right? They're not unrelated things. And they became different over time through that concept that was very new at the time of evolution, right? Darwin's grandpa, Erasmus Darwin, right? Because when we talk Darwin later, we're going to be talking Charles Darwin for sure. But Erasmus Darwin, after Buffon, he started proposing different mechanisms that could explain how that evolution works, right? One of which could just be simple competition, right? Which, again, you expand on that a little bit, start talking survival of the fittest. That's where Charles Darwin got his ideas, right? Lamarck also was mentioned in this section, and he was talking about how things change with a changing environment, change to and because of their environment. Now, he did get a few things wrong in there, Lamarck did. Right? He's the one that actually thought that maybe use and disuse would change an organism. So the fact that a horse had to stretch his neck over and over again to reach leaves up in a tree, that's how we got a giraffe, right? Now, we don't believe that. We don't think that an organism changes in its lifetime because of use or disuse. But if you happen to be born with a slightly longer neck and that gives you an advantage, maybe that could get passed on. Maybe that could lead to evolution in that species. So obviously, a lot of things changed from the time when these guys were first discussing these ideas. But we just need to understand what everyone contributed, right? And we'll catch up on Charles Darwin later for sure. But make sure these guys are in your notes so you know what they did. Otherwise, this question, talking about how we once believed, it was very common to believe that the Earth was only 6,000 years old because that's what a book told everybody was true, right? So if you're going to look at a Bible literally, you would believe that the Earth is 6,000 years old-ish, right? And if you were just going to look around yourself and not take a bigger perspective, you might assume that the Earth is constant and unchanging, that everything is the way it always was. Right? But then we started finding evidence to see that Earth changed. Right? So then we have these three theories of geological change in succession. Right? We need to know how they're similar, how they're different. I already talked about them a little bit, so we just need to jot down some notes. So remember, I told you that catastrophism and your gradualism, uniformitarianism the gradualism and uniformitarianism, they're essentially the same thing. But catastrophism is very different, right? So catastrophism, we're dealing with abrupt, very quick changes, right? Because we're assuming it's an earthquake, a great flood. We think that there are these natural disasters that cause change. Now, we do actually think that natural disasters can affect evolution, right? We do think that an asteroid striking this planet could knock out an entire species, right? Like those dinosaurs. So it's not to say that that can't be what happens, but that's actually not what usually occurs, right? So yeah, there are some periods of abrupt changes in Earth's history, but mostly it's gradual, right? So obviously gradualism, we're talking more like gradual change, because that's what it says in the name, right? But uniformitarianism would add in that gradual change is ongoing and constant. So not only is Earth changing, did it change, but it will still, right? It's always changing, and that rate is constant, right? And we're not going to be talking about natural disasters in this case. We're talking about mechanisms like erosion, very slow processes, right? It would have taken millions of years for that Colorado River to dig out the Grand Canyon. That's essentially what it did. So different viewpoints with entirely different outcomes, right? Understand that we went away from that catastrophism for a reason. We know that that can still affect species, but mostly Earth changes slowly, right? But it it's constantly changing, and that's ongoing. That's the important part. And finally, if you were going to answer this question, quiz or test, right? The idea is that Earth undergoes gradual change and is billions of years old, important for evolutionary theory. Understand there are actually two parts to this question. That's what makes it kind of hard. But since I'm going to give you an answer, you should be able to deal with it on a quiz or a test, right? So you can answer however you want, but essentially, we're talking about organisms. Again, I'm lazy sometimes. That's organisms. They're going to change, not just randomly, but with their changing environment. They change because their environment changes. If their environment didn't change and they're already suited to their environment, there'd be no reason for them to change. So organisms change with changing environments. Which essentially is your first part of this question, right? Second part of the question, why is the fact that the Earth is billions of years old important? Well, essentially because change takes time. Right? If we're talking about erosion, if we're talking about gradualism, if we're talking about evolution, all of those things take time, right? So evolution takes time, right? We have to understand that if we really believed that the Earth was 6,000 years old, there's no way the Grand Canyon could have been dug out by erosion. There's no way that one organism could change so much that it turns into a completely different one, right? So we got to add in that part of this explanation too, right? The fact that Earth changes, period, and the fact that it's really, really old, both of those things are very important for evolutionary theory. Right, so that's our whole section there.